This brings us to the next speaker of the session. I would like to invite Mr. VINEET Sehgal. Mr. VINEET Sehgal is the Chief Human Resources Officer, ESSAR Oil and Gas Exploration and Production Limited. Mr. VINEET Sehgal joined ESSAR Oil and Gas Exploration and Production Limited in December 2018 as VP Operations and took over as the company's CHRO last year. Mr. Singhal has 35 years of experience in upstream oil and gas, both offshore and onshore, covering practically all facets of the industry. Earlier, he has worked with E&P majors in India, ONGC for 20 years, and abroad, Kuwait Oil Company for 12 years, and has spent a major part of his career on formidable and large gas facilities and projects, including LNG. He holds an honors bachelor's degree in chemical engineering from University of Guwahati, and his areas of expertise include facility engineering, flare management, process safety management, and flow measurement, in which he has published and presented papers in international conferences. We would like to welcome Mr. VINEET Singhal from ESSAR Oil and Gas. Over to you, sir.
Yeah, good afternoon, everyone. Am I audible, Ms. Shivani?
Yes, sir.
And is the video visible also?
Yes, sir. The video is also visible.
Okay.
Yes, sir.
First of all, let me thank this this World of Chemicals for holding such an webinar of this eminence. And truly speaking, I am overwhelmed by the one or two last, especially without any offenses to the other speakers. Mr. Pramod, your presentation was amazing. I'm really floored. And I was thinking whether I should be speaking at all. और आपका प्रोफाइल इतना impressive है, 20 patents लेके बैठे हैं आप. Hats off to you. Really, I'm floored. And after this conference, I would like to speak to you. Now, coming back to this topic, I wasn't really prepared. There was very short time. So, in fact, I would have loved to share a presentation, but Ms. Shivani, I'm sorry for this. This time I will not be able to put up a presentation, but I'll speak on something which might interest the viewers and the other participants, the speakers and the other participants. So as Ms. Shivani has said, I'm fascinated by flare management and flow measurement mainly. So, flaring, flaring is a flare system is common to all the facilities in hydrocarbon sector, whether it is upstream, midstream or downstream, for which we have all the participants coming from, which sectors we have participants coming from. And everybody's endeavor is to reduce the flaring to the bare minimum. So we have something called, let's say, zero flaring. I would only add that zero flaring is a misnomer. What we can do is we can minimize flaring and bring it to almost zero levels. But zero flaring would be possible only if you had put up a blind flange on the flare stack, but which is not possible. So we should, before we move to flare management, we should know what really are the definitions of flaring. So I would suggest our audience our participants to have a look at a very informative site of the World Bank. It's called GGFR, Global Gas Flaring Reduction Program, and they have a lot of data, the flaring data across of all the companies and countries across the world, and more importantly, what constitutes flaring. So when these definitions were being framed in 2016, I used to work for Kuwait Oil Company, and I was a part of the team that was looking into these definitions. So basically, there are three sectors of flaring. One is routine flaring, the other is safety flaring, and the third is non-routine flaring. So the endeavor of the world is to reduce the routine flaring to zero. Routine flaring would something which you are producing an X amount of gas, but your facilities can handle X minus delta X. So that delta X is what you're consistently flaring 365 days a year. So that is what is meant by routine flaring, and which is to be avoided. Now, safety flaring would include something, let's say, blowdowns. If a blowdown valve is opening or a PSV is opening up, or let's say there is some release or venting to depressurize an equipment, that would be safety flaring. And more importantly, let's say the purge gas to maintain the positive flow, and even the fuel gas for the pilot, they are all included under safety flaring. The third is non-routine flaring, which encompasses all the flaring due to compressor trips, equipment trips, and when you have to take a preventive shutdown or you are starting up the plant. So these are non-routine flaring. So much about the definitions. Second thing is, if you want to reduce flaring, you have to measure it properly. I mean, I would say that you can't control something which you can't measure properly. So you have to have a very good system to measure your flare. What most companies do is that when they specify a flare meter, they start from the purge gas, which runs into only a few tens of nm³ per hour, and they want to capture the peak flaring, the fire load or the block discharge or whatever is higher. So there is no meter in the world which would have such a high turn down. But the specifications are such that every vendor tries to sell their meter and say that they have the best meter in the world. So what I would suggest is that we should be very careful and read between the lines when these vendors come up with their proposals and their literature. So the best way would be to measure purge gas and pilot gas to rotameters, which is the only meter to measure such low flow rates. And for the peak loads and the normal and the peak loads, we would rather put up an ultrasonic flare gas meter. Now, there is something, the third area I would like to touch upon is the OSD requirements for spacing between the flare stack and the other facilities. If the most common standard that we refer to is OSD 118, which puts up a requirement of a sterile area of 90-meter radius. Now, it is a very paradoxical requirement. On onshore plants, they insist upon this radius being maintained. So 90 and 90, the diameter is 180 meters. So all refineries do not have. I mean, I'm not questioning or challenging, but I'm pretty sure there will be a lot of refineries in India or abroad which will not be having this sterile area. It's difficult to maintain in a city. If the refinery is in the outskirts, it is possible, but if it is bang in the city, it is difficult. And let me give you an example. A FPSO, a floating production and storage unit, which also has a let's say a flare stack and handles, let's say, around 2 million barrels of oil per day. So that facility, the largest, I was looking at the literature, the widest FPSO is about 60 meters in diameter. Now 60 meters diameter, 60 meters की width है उसकी अगर FPSO की, तो उसमें 90 meters का radius आप कहाँ से लाइएगा? तो अलग-अलग standards लगाए जाते हैं. We are imposing different standards for different facilities, which perplexes all designers. Facility when they are doing a conceptual design of a facility, where to locate the stack. And there is something. I mean, the standard says that you should not have anything in that sterile area, 90-meter radius. Now, the flame front generator, which ignites the pilot in case of failure, it has a limitation. So, I mean, that flame fireball cannot travel for more than about 100, 105, 150 meters. So that's on the threshold of this radius. अगर 30 meters का stack है और आपका 90 meters का radius है, तो 120 मीटर ये हो गया आपका. So it is difficult. This becomes a challenge where to put the flame front generator, unless it is electric, of course. If it is an electric spark plug, the problem is solved. Another paradox and something which I wanted to share was about let's say we have a gas. Our plant is handling a gas which has 15% H2S. Hypothetically speaking, And it's not hypothetical in upstream. In Kuwait, we used to have gas which had almost 11% H2S, and there are instances, locations in the world where the H2S content is as high as 60%. So if you have to flare that gas, release that gas, would you rather burn it or release it unburnt? If I release it unburnt, it goes as H2S. And excuse me, just a moment, please. I'm very sorry. So would we rather release that gas unburnt as H2S, which is also toxic, or would we burn it, in which case it would get converted to SO2, which is again very toxic. So this becomes very debatable because the toxicity levels in terms of STL are not very they are not way different, but the molecular weight of SO2 is almost double of that of H2S, so it tends to settle down. So it is, a case, it becomes a paradox. And in fact, I would like to hear what my other participants of this conference or other speakers have to say on this. It bothers me. I try to read a lot on the net, but could not find a good solution to it. And coming to metering of flare gas, as I said, we would rather put an ultrasonic gas flow meter, intrusive or non-intrusive clamp. But clamp on would not give good results. And I would also suggest something. Let us not go for very high accuracy meters, because the European Union has put up has given us a good margin for accuracy of the meters. I mean, depending upon the carbon release, they have set limits of 3.5% error, and it can go even up to 7% is acceptable if the quantum is different. I mean, they've set the CO2 emission levels versus the accuracy. You can find it on the internet. It's available. Well, I'm sorry to stop very abruptly. Ms. Shivani, this would be all that I have to say, because we had some pressing things coming up in between, and I could not really devote much time. I feel sorry about it, but that should be about it. But I'm definitely ready to answer any question that the speakers or the participants would put up to me.
Okay, sir. So we look into it. What are the questions that are coming up? But very important point you touched about was flaring. A lot of importance is being put into flaring, in say oil and gas, refining, petrochemical, because a lot of flaring concerns are coming up. And since we are going to grow in such a level in the petrochemical industry, I think flaring will become a thing, that we need to look into. And you mentioned the routine flaring and the safety flaring, and reach it out to zero emissions, then measuring it properly, and then taking a decision whether to burn it or to release it, and how it's going to affect the atmosphere in the future. Definitely these are points the industry will consider, and I think a lot of work is going in this segment as well. Thank you for your input, sir.